6.2 RSG. This video is going to be a little bit longer than the 6.1, but you may not need all of it. The ready and the go are just review, so I'm going to spend most of my time on this set. So I'm just going to get you started on what is required for the ready. So in number 1 through whatever it is, 4, forgive my brain, it is having a hard time working right now. We're writing the intervals where the graph is positive and where the graph is negative. Positive is above the x-axis, and negative is, that's supposed to be a B, below the x-axis. So you need to make sure you understand that distinction between positive and negative. So if here's my x-axis, the positive are the pieces that are above, where the negative is the pieces below. And when you are writing your intervals, it is from x to x. So if I'm going to start with the positive, that's the green, and this x is -2. And since it is above, it gets a bracket. And this x is 0, and since it's on it, it gets a parenthesis. This one, 1, 2, 3, 4. So parenthesis 4. And it's above all the way until 5, 6, 7. Both parentheses. And then the below will be from here to here. So it's what was in the middle. So 0 to 4. So there will be that connection here, but just don't forget it's the x values. And so these are all the x values, and positive or above, negative or below. When you get to 3 and 4, just be careful. It says this scale on the x-axis is in 45-degree increments. So this is, let me make this smaller, 45, 90. You keep adding 45. Okay, so you actually are going to be dealing with bigger numbers, and above is positive, below is negative. So that's the ready. I have not taught you how to write equations for piecewise functions, so you don't need to do that. If you want just to practice, you are welcome to write the equations of each of these. Pretend that they are a line that is actually continuing on forever. So you can do that. You can say, oh, here's this line, and you can write the equation. Here's this line, write the equation. Eventually, I am going to teach you how to do this, but it's only really going to be for those of you going on to calculus. You are going to need that for next year. So I will be going over it towards the end of the semester as you guys are doing your practice for that. All of you are going to get it, but those of you going on to calculus, you are going to need it. So we will get to it eventually. Okay, the set. I'm going to spend some time here not doing the task with you guys. It's going to take a little bit more work for this. You are going to use this Ferris wheel, and we are going to fill in this chart down here. What this whole problem is asking is where the rider is at a certain time. How high are they off of the ground? To do this, we need to write an equation. That's just the easiest way to do this. The task would have us going through and making these triangles like you see here in the diagram that they're giving you. So we're not going to go through that entire process of making a triangle for every single one of these. I'm going to use the information that they're giving me about the radius and the center of the Ferris wheel. So I know the radius is 25 feet. Okay, so each of these spokes is 25 feet. But the center is 30 feet off the ground. Okay, so that means this part is 25 and this part is 5 for a total of 30. Let me actually not use the highlighter. So this would be 25, but here would be 5. So to write my equation for this, I need to, sorry guys, there's just a lot of noise going on around, just ignore it. I need to pay attention to how fast the Ferris wheel is spinning around in a circle, so I can figure out the height for a certain time. So when it's saying that the full rotation, that's one revolution. So to go from A all the way around back to A takes 30 seconds. That's what that is telling me. To go all the way around is 30 seconds. I need to figure out how far that Ferris wheel is moving per second. I don't want this in 30 seconds. I want how many degrees per second. Yes, they're giving me this triangle that is saying it's 36 degrees, but that's not telling me how far it is moving per second. I want per second. So not too bad. It's not really difficult to do this. There are 360 degrees and it is traveling 30 seconds. So 360 degrees for 30 seconds, which is going to end up giving me 12 degrees per second. So every second that Ferris wheel is going 12 degrees more. So I'm going to use this information and I'm going to write an equation to help me figure this out. If we were doing the task, we would have discovered how to write the equation for this. So here I'm just going to give it to you. The 30 is actually representing the center height. Okay, and we're going to need this later on. So the beginning number is my center height. The value with sign is my radius. Then this inside, T is representing your time, and 12 is the degree per second. So there's a lot of information to this equation. We're going to continue to use this equation over and over and over with different times. So just something to maybe write down. You definitely probably want to write this stuff in red down. So in 7, when it's saying calculate how high a rider will be 2 seconds after passing position A, for T, you would plug in 2. So this would be 30 plus 25 sine of 12 times 2. Be careful, because in your calculator, you have to make sure you're using parentheses. I would simplify this down to 24. So in your calculator, you can put 30 plus 25 sine of 24. You cannot add 30 and 25. The 25 is attached to sine, so you cannot add the 30 and the 25. Okay, please make sure you plug it into your calculator like this, and then you're going to go through that process for all of these. Where it says calculations, you would plug this in, and then obviously your answer for the height of the rider. So it's just going to take some practice. Don't worry about when it's saying, put it on the diagram, draw vertical lines, make triangles. You don't need to follow these directions. Just find the height. Practice using that equation to find the height. Don't worry about 9, 10, and 11. Since I'm not here to do the task, I know I am asking you guys to do that on your assignment sheet, I believe. But you guys really don't need to stress about that. For number 12, it's asking you to describe the relationship between the orientation of the triangles, the right triangles, around the circle. Use what we did on the unit circle. So you want to think about the symmetry. Okay, you want to think about reflections, maybe some rotations. So think about the symmetry that we used to create our unit circle. And I have these triangles as A, B, C, D, so instead of you guys, trying to describe this just saying triangle, 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 tell me about triangle A and B, A and C, A and D, B and D. Tell me how we go from one triangle to the to the other. Okay, what is happening to go in those directions? So a brief summary about that. And then on the go, this is review, so hopefully it won't be too bad. Find the measure of each acute angle, which means the non-right. So acute means the non-right angles of the triangle. So I strongly suggest that you just go through and draw a right triangle. Here's my right angle. If I say that this is A, this is B, my right angle is C. So little a has to go across from big A. So here's little a, 3. C has to go across from C, so 5. So now to find your angle measures, when it says find the acute angles, these are what you're looking for. You're looking for A and B. So I need to pick one. So if I'm going to say A is my theta, 3 is opposite, 5 is the hypotenuse. Oh, SOHCAHTOA. SOHCAHTOA. Well, if I have opposite and hypotenuse, what uses opposite and hypotenuse? Sine. So this is going to be the sine of A, since I'm trying to find angle A. Opposite is 3. Hypotenuse is 5. When you're looking for an angle measure, we need to remember we have to find the inverse. So A is going to equal sine inverse of 3 over 5. And then I need to make sure my calculator is in degree. So sine inverse, actually let me check, I haven't checked mine. Okay, it's in degree. Sine inverse, make sure you're using parentheses, 3 divided by 5, close the parentheses, and angle A is 36.9 degrees. Now angle B is actually easier to find. It's 90 minus, well, you would add the two angles up and then subtract them from 180, or 90 minus the 36.9. 90 minus 36.9, and I end with, for angle B, 53.1 degrees. So not too bad. Okay, and some of you, you're going to see patterns and you're not going to need to draw the triangle all the time. And that is perfect if you can do that. If not, draw your triangles. It's not going to take you that long to draw triangles here. Okay, that's it for 6.2. Save any questions you have for when I return.